What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to look at part 11 of our data visualization with Python tutorial series, in which we explore the MatPlotLib package. So guys, if you have been following along, I've mentioned in the previous video that in this video onwards, over the next few videos rather, essentially what we will be looking at is the concept of working with annotations, okay, adding annotations to our visualizations. So just to give you a bit of perspective, right, in general, right, it is often said that I think one of the best ways to actually create or design a visualization is giving that visualization the ability to be self-explanatory to the viewers. Now, in some times, right, in some situations, it can be difficult to kind of interpret a graph or a visualization, because ask yourself, how do people interpret this graph? For example, take a look at the previous visualization we plotted. Fine, all good. This visualization looks good. It depicts data, but the questions we may ask now with regards to the interpretation and explanation of this plot is: number one, how must I read this graph? Okay. Number two, what is the title of this graph? What am I being presented with? Okay. Number three, the x-axis and the y-axis. How do I interpret the vertical and the horizontal axes? What quantity is being represented by the data points, by the curve or the gradient itself? Okay, so that's just like a few examples of stuff that you can ask. So that's basically the questions we are going to answer in this specific portion of the series. Having the ability to annotate or add annotations to a figure. Now, the first things first, I think we'll start off with something basic. Something you guys are probably wondering, how do we adding a title to a plot? So this is probably the easiest annotation that you can actually add to any plot that you design. So go ahead, import numpy as well as matplotlib.pyplot as plt. So I'll just keep this copied on my clipboard in case we need to retype the importations. So this syntax is something that I do not want you to be focused on. What we are doing here is simply generating some dummy data for us to work with. So we'll do x is equals to numpy.linspace -4, 4, and let's do 1024. Now we'll set up some y values for the data itself. Let's do 0.25 multiplied by x plus 4, and here we can say multiplied by x plus 1 multiplied by x minus 2. Okay, that's the polynomial that we have here. So what we can do is we will simply proceed to annotate this graph. So under usual circumstances, what we would do is plt.plot, considering that we are plotting a line graph, then we'd pass in the parameters themselves. So x, y, and we can do color is equals to, let's set it to black. After that is done, what we would do is plt.show, and that would have concluded. But now we want an annotation added to this graph that we are going to plot. We want a title to show. So what we can do is utilize plt.title, and within this function, title function of the plt or matplotlib.pyplot package, we pass in label. That's the name of the parameter, and it takes a string. So what we'll do is, let's just call this a polynomial. So if I do control enter, as you guys see, this is what we obtain. a polynomial graph, but the interesting and important thing to take note of is the fact that there is a title now that shows on the display itself, as you guys can see that. So that is what we have for adding a title. So the next thing you'd like to do is maybe with regards to still pertaining to the concept of annotations, another interesting and fascinating thing that we can do is adding labels to the x and the y axes. So let's do adding labels to the x and y axes. So I copied the previous questions or examples code because we are using the same curve for this specific, demonstration. Now, I'd like to mention that whether you place the title, the annotation code before or after plotting, it really does not affect, the graph itself in any way. You'll still have those annotations showing because at the end of the day, as I described in previous videos, the plt.show is what ultimately plots and draws everything on the canvas that has been described previously. So order does not really matter. So just for us to have some sort of standardization in the code, we will call and code annotations before plotting the function or the curve itself. So let me add now an x and a y label. First, let's do the x label. We can do plt.x label, and within this, x label is the name of the parameter. It takes a string. So what we can pass is a title or a heading for the x-axis. So let's just call this air speed. And now we'll proceed to do a y label, plt.y label. And I can call this maybe total drag. So that is good, and let's just change this title since this is a different graph in inverted commas. Let's do power curve for a foil KV873. So that adds a bit of fanciness to our plot. So control enter, run your script and view and observe what we obtain. We have a very neatly formatted plot that's showing now with a title as well as headings for the x and the y axis that we see. And yeah, that's about it for the label aspects for the x and the y label. So with regards to more annotations that we can do, I would like to demonstrate for you guys the ability to add text. This is an interesting one. So adding text to our plot. So this is what we have here. Now I should mention, right, we are doing it for a line graph at the moment. So I'd like to mention that you can use it for bar plots, scatter plots, majority of the graphs themselves, they will support, guys, the concept of titles, x-axis, y-axis, majority of the annotations that we do. A question now that comes to me is, I'm not sure if you can add x and y labels for a pie chart. That does not make sense, so I doubt you'll be able to use that for pie charts, but definitely the title will work, so that is fine. Now let's proceed to import again. So import numpy as np, import matplotlib dot pyplot as plt. So just a reminder, we are now adding text to our plot. So let's actually do that. Now what I want to do is x is equals to numpy dot linspace start stop. We'll give it the same as before, -441024. Y is equals to 0.25 multiplied by, or instead let me be smart and let me copy this code here. Okay, so there we have the same x and y data points that we are working with. So what we want to do now is plt dot text. Okay, plt dot text. That is the important portions that we need to pay attention to. And what I'd like to mention is, before actually telling you guys, I want you guys to view documentation. Please do not forget, guys, that you have the ability to view documentation for building more insight into a concept that we are working with. So x and y is easy, right? All it is referring to is the x and y position, like with regards to the x and y axis themselves, about where we want to place the text. So as it says, right, by default, this is in the data coordinates. What this means is that it's using the x and y scales that we have existing on that current plot. Okay, so keep that in mind. So this explains now why we are going to pass the values that we are going to pass. So I will do negative 0.5, which means that the text is going to start being drawn from negative 0.5 on the x. So that's around here where my cursor is currently. It's here, negative 0.5. And now let's pass the appropriate y value. Let's do negative 0.25. So if we pay careful attention, right, negative 0.5 is here and negative 0.25 is around here. Okay, so negative 0.25 would be somewhere here, which means the text would appear around here. I hope you guys can see. Oh, my bad, I think I was pointing to the wrong x coordinate, but anyway, negative 0.5 is here and negative 0.25 is here. So within this dip of the graph itself, where the gradient dips, that's where we should expect to see the text. And you guys know, right, the position of the text is not going to be changed every time we run the script, because these coordinates are hard coded by us. We have explicitly said where we want the text to be placed. Now x and y are just two of the compulsory parameters that we need to pass. The third compulsory one is what's known as s, as you guys can see on the screen. S is actually representing the string of text that we want to kind of place on the graph. So let's do this as bracket, or let's do bracket minimum. So these are all mathematical concepts that I am pulling out of the sources. If you don't understand it, that's not to worry, because I mean, that's not important. What's important is you understand the method and the technique that is used to go about solving a problem. In this case, the problem or situation we are faced with is, how do we add text to our plot? And as we see, we utilize plt.text, pass the x, y, and the string we want to shove into the graph. So that is fine. Now plt dot plot, what we are plotting is x, y, and color. Let's leave this a standard black. So plt dot show, and as you guys will see, this is what we have. We have here a bracket or bracket minimum. Okay, now this is fine. Now, can you imagine how powerful this graph will look if we have to combine several annotations into this graph? So all I did was copy title, x and y labels from the previous block of code, and I added it, to the cell that we are working with currently. So when I run this script, what you will see is, the more annotations we are adding to the graph, the more meaningful the graph is becoming. It's becoming self-explanatory for us. Okay, and to avoid overlap of the word minimum on the gradient itself, you guys can play around, right? I want you guys to just spend a few minutes, try to play around with these x and y coordinates, and try to get the text bracket minimum to show a bit higher up, so it does not touch the line or the gradient itself. So yeah, that is interesting stuff for you to play around with there. Now That was the concept of adding text to a plot. That's fine. Now, the next thing I'd like to, sort of demonstrate for you is maybe with regards to the concept of adding arrows to a graph. So let me create a new cell, adding arrows to a plot. So let's go ahead. I'm going to copy the importations as well as the x and y values from our previous cell. Now what I'd like to do is remember guys, we are trying to add an arrow to the graph. Okay, so this is how it is done. Let's do plt dot plot. Remember guys, this is me showing you under normal situations or normal circumstances, this is what we would do. Plt.plot, plt.show, that will give us the curve that we see. Now what we want, or what we are looking for, is how do we add an arrow to the graph. So the way in which we do this is using the annotation method. So plt dot annotate, as you guys can see, the annotate is built into MatPlotLib.pyplot. The important arguments or parameters that I'd like to draw your attention to are as follows. So let me pull up the documentation as well so I do not miss out anything important. So this is what I would like you to focus on. Text. That is the first one I'd like to code for us. I will space this out here, make it a bit neat for you. So text, let us fill in the text. We'll fill in the names of the parameters and their arguments at the same time, right? So text is equals to, let's copy, or let's just use the same one, Brackmed minimum. Okay, that's the first parameter. The second parameter that I'd like to draw your attention to is what's called HA. So I see the documentation does not really have that, or even if it does, I cannot see it. Anyway, HA stands for horizontal anchor, right? In case you are wondering. Now, this is nothing difficult, guys. You know, like how in Microsoft Word, we have the ability to center text according to a certain text box. So essentially, this is what the horizontal anchor does for us. It anchors the text horizontally. Horizontally, in case you forget, is from left to right. So we'll have the ability to center it left, right, or center. So let's do center. Now, obviously, if there is a horizontal anchor, there is definitely a vertical anchor. Vertical allows us to align stuff, you know, top, middle, bottom. So let's do bottom. Now, those are three parameters that are useful so far. The next one, I actually saw it here, as you can see, is XY text. XY text is the position XY to place the text at. The coordinate system is determined by text coords. Okay, text coords, well, don't pay attention to that. Just know that it utilizes the exact same coordinate system that is being shown or kind of used on the plot itself. Very similar to the concept of adding text itself. So all we are doing here is we are adding text, but there'll be an arrow that kind of points to where the text is placed. So nothing too difficult there. XY text is equals to where we want the text to be placed. So let's do here, guys, I should mention, please pass XY text in the form of a tuple and pass the XY coordinates that you'd like to sit the text at. So we'll keep it simple for this one. What we'll do is maybe an X value of negative 1.5, and we will pass a Y value of 3. That is another parameter, XY text. The next parameter that's important is X xy also takes a tuple. I saw it here. Here it is. The point xy to annotate the coordinate system. Don't worry about that, guys. Xy is using the same coordinates as the plot that we are working with. Okay, so what you will see now is that xy, let me comment this, I don't want you guys getting confused. So xy, yeah, that will be fine. Now keep in mind, right, that xy itself is actually referring to where the arrow is pointing. So let me comment. XY refers to where the arrow points, right? And as implied by the name of this parameter itself, XY text is the start point of the, so let me say is the x/y start point of the text itself. Please don't get confused, guys. The point of annotations when you are plotting an arrow, you have to cater for x and y values for the text itself, the words, as well as where that arrowhead is pointing to. In this case, the arrowhead for us will point at x, y, and the coordinates we'll pass this will be 0.75 and negative 2.7. So let me bring you guys to this plot. Think about it, right? We want the arrow to point at 0.75 on the x. So 0.75 is around here where my cursor is, and negative 2.7. Negative 2.7 will be lower than this. So the graph will be kind of adjusted appropriately, right? But now xy text, where is the text going to show? At the x value of negative 1.5. So negative 1.5 is around here, and the y for that was 3, so around maybe here. So this is where the text will be placed. The arrow will point diagonally from here towards the right, and the arrow is pointing towards this curve here. So if that does not make sense, I don't really stress about that. I don't really want you guys getting confused. That was just me trying to explain, right, before you actually look at what exactly it is that we did. So arrow, so this here is another parameter, arrow props. Arrow props, really, it refers to us having the ability to pass a dictionary of arguments that actually control the arrow itself. Okay, the styling of the arrow itself. Two important arguments that I'd like to, introduce you to at this point. These are probably the only ones you are likely to use. Is face color. This is the actual color of the arrow itself. Let's keep this a standard black color, and we'll have the ability to do shrink. Now the shrink, if you are wondering, right, the shrink argument that we are using and that you see, it basically controls the gap between the arrow's endpoints and the arrow itself, the gap between the arrow. Okay, that's what it controls, the shrink parameter. So if that does not make sense, please don't stress about it, especially if this is the first time you are, kind of working with this. The more you get accustomed to using it, the easier and more understanding you will have. Now, I will run the script, I will change a few parameters, and I'll run it again so you can see the effect that the parameters have on the arrow and the text itself. So I do a control enter. Let me quit the documentation. And here we see this is what we have. We were expecting this, guys. This is exactly what we were expecting. So that's that. Now, in case you are wondering, right, what effect do these kind of, parameters have on the arrow? So face color, let's make this blue. I think blue would look fancy, or maybe even red would look good. I changed it, the shrink parameter, from 0.05 to 1. What else can I do? So I think that will be fine. The text, will leave it as such. Yeah, so control enter. Have a look at this, guys. This is what we see by default, right? So notice that the arrow now is extending, kind of onto the line itself. So if I tamper with this shrink parameter, so let me make it 0.01. Pay careful attention, guys. I'm not too sure if you noticed that, but there was a slight decrease in the size of the arrow itself. So let me do this. 0.05. So if you pay careful attention to the arrow, guys, you will see a slight increase in the size of the arrow, or decrease rather. So that's what we observe. Now let me actually comment here. Okay, guys, so I will comment here and say the shrink parameter will affect the tip and base of the arrow itself. Basically, guys, what the shrink does is, you see it, by some percent you will move the tip and the base away from the annotated point and the text. So that point that we specified where the arrow should point, the shrink parameter and the argument itself will move those, or the arrow itself, a certain percentage away. So obviously the greater the number you specify, the further away it will be moved. So I can do 0.1, and as you guys can see, it is being shrunk. Okay, it is getting smaller. This is an interesting thing for you to play around with, guys, and I just hope that it is making sense to you. You guys can leave a comment down below, and I'll be glad to assist if you have any questions. So I think before I conclude this video, guys, there is one more thing that I'd like to show you. It is a very interesting thing. So it is called adding a legend to a plot. Now, I'm not sure if you guys are familiar with what a legend is. There is another name for it that I cannot really remember, but basically, guys, when you have several graphs or gradients on one canvas, essentially sometimes what we'll do is we'll make each gradient a different kind of pattern. So maybe one gradient will be solid, one gradient will be dotted, another can be dash dotted, and so on. And then on the plot itself, we'd have a little box, and we'd kind of map each of those gradients to what they represent. Okay, so that's basically what a legend is. There is another name for it, but it's just not coming to me, right? So that's fine. What I'd like to do is import numpy as an np, import matplotlib dot pyplot as plt. Now x is equals to numpy dot linspace. Within this, let's do 0, 6, 1024. For our first graph, let's keep it simple. Let's do a y1 is equals to numpy dot sign, and let's do x. Y2 is equals to numpy dot np.cos of x. So these are our trigonometry graphs. Now plt.x label, and within this, let's pass the x label of x. plt.y label, let's pass a label of y. So we are kind of cheating the system here. In actual sense, you'd pass some appropriate and meaningful headings for those axes. So plt, this is the next portion. It is time to plot the graphs themselves. Now let's do plt dot plot. Let's do x and y1. I'd like to do color is equals to k, So that's basically color is equals to black. Now let's do label is equals to, let's do it in small, so sign of x. Pay attention guys, please pay attention to this parameter. The parameter is called label. That's the important one. So plt dot plot x y2 c is equals to, let's make this fancy, let's set this to red, and we'll do label is equals to cos of x plt dot show. Now please pay attention to this guys, I want you guys to pay attention. When I run the script, we are just going to observe a graph, right? As you can see, it's a simple sine and cos graph that we study in math. The graph itself is not important. We want the legend. Question is, where is the legend? Okay, in order to actually plot or show the legend on the graph itself, we need to use a method called plt.legend, and all we need to do is just call it. You may call it with an empty parenthesis, okay? plt.legend, open close parenthesis, and that's it. Automatically, this function, right, will automatically find those plots that have been described before it, as you can see, described before it, and it will take the appropriate label parameter that has been set in each one, and it will map it to the line, the color of the line or gradient itself. So as you can see, the sine graph is the black gradient, the cos graph is the red gradient. How do we know if this is correct? It's because if we look at the actual descriptions of the graphs themselves, we'd also see that the label for the sine graph must be assigned to the black gradient. And as we see on the legend itself, the black gradient is assigned to the sine graph. So it is super interesting. And just as a reminder, you guys should know and picture this. How powerful can you make your visualizations if you add a title, if you add annotations, if you add text, as well as X and Y labels and so on, that are all meaningful and pertain to this plot? Okay, you will really give yourself the professional, look, especially for your visualizations. So that's that. Now, to make this even, more, I would say, like to level this up one level higher, what you can do is line style. We did cover this in a previous video, if I'm not mistaken. It is another parameter that is supported by these graphs that we work with. So it is called line style. If I'm not mistaken, MatPlotLib will also, like, since those parameters are so long to type, line style as well as line width, you'll have the ability to actually call them. So let me just make this ls and lw. So if anytime guys you come across these parameters ls and lw, please do not be intimidated or confused. They are the shorthand that are supported for line style and line width. So I'll type it out full since we are not lazy, so that's fine. So line style, let's do this as maybe let's leave this as is, so I won't specify anything there. But considering I want to make the second one, the cos graph, a dashed sort of line. So as you can see, the point was for me to just show you that the style of the line itself is also propagated into the legend. So as you see, and I've spoken enough for this video. We will end this video here, guys. I hope you guys are finding this interesting. I hope you are having as much fun, learning and absorbing the information as I am teaching and learning along with you. So with this, guys, we will end this video here. Thanks for your time. Thanks for watching. And I'll see you in the next YouTube video. Good luck with your work.